So in this demo, I'm going to be explaining how you can run a single patient level prediction study. So I'm going to be using the connection details that I've saved and described in the previous demo. And I'm going to be using some other settings that I have sourced, but just to explain what they are. So the CDM database schema, which you see here, this is just going to be a string that specifies the common data model database that you actually have access to. And then the cohort database schema, this is the database schema, again as a string, and this is where your cohort tables are found. And then the cohort IDs and the outcome IDs that I'll be using in this study are for two different cohorts are listed there. This is the connection details using the connection detail.r, as I previously explained. And then the first new thing that you're going to get to in this study is this create covariate settings in feature extraction. So this is a function that you can input different settings for creating the covariates, aka the features you're going to be doing in your prediction study. So the first one that there's actually a lot of different covariate settings which is shown in the helper function here. I actually recommend just looking at them manually yourself because there's too many really to go through. But eventually it's going to be all conditions, drugs, procedures, measurements, observations, and some healthcare utility and demographics. But for this example, I'm going to pick some simple ones just to demonstrate the look back period and also the different settings that you can have. So we have this demographic age group. So this is your age in 5-year increments, as in groups, and that's going to be included as a covariate. And then the next one is the gender, so whether they're male or female, it's going to be included. And then we've got this condition group short term, and then we're also going to have condition group error medium term, condition group error long term, and then condition error anytime prior. So I've picked 4 different time periods because we're going to be explaining how to do that. So all of these ones, anytime prior is going to look back through all the records you have prior to your target cohort start date. But the long-term one is only going to look back this amount of days. So there's long-term start dates, which in this case is only 1 year prior to your cohort start date. So you're only going to look at conditions that are recorded in the 1 year prior. The medium only looks at the ones that are recorded in the minus 90 days, so the 90 days prior to your cohort start date. And then the short term is only going to be looking at the minus 30 days. So this is what's going to be different between these different conditions variables. And then the end days is how close to the cohort start date for your target population do you end looking at the records. So -1 means that we don't use the cohort start date. We actually end 1 day before your cohort start date. And this sometimes you want to include your cohort start date, sometimes you don't. If you want to include your cohort start date, make your end dates 0, and that means you'll be using all the records up to your cohort start date if your end date is 0. So there's a lot of settings here you can set. There's lots of different variables, but for now we're just going to keep to these ones. I'm just going to run through all of this now just to get it all set up. So I'm going to set up the connection and I'm going to set up the covariate settings. So if this all runs, you get no errors, it's all good. The next part is your get PLP data. So this is where we're actually going to be accessing the CDM, accessing our cohort tables and extracting the data. First input, connection details we set up. Then we've got the database schema where our CDM is found, that's the string. Then we've got our cohort and outcome IDs, so we know which ones from the cohort table to extract. And then we're going to have our cohort and outcome database schemas. This is where the cohort tables are found. I've just set these to the same cohort database schema. And then we're going to have the cohort and outcome tables. And again, I'm just using the cohort table in the CDM. The next input is the covariate settings. So this is what we just set above. And then we've got this sample size. So this is whether you want to sample from your target population. If you want to use everyone, then you set this to null. But if you want to sample so that you can speed up the whole prediction process, or maybe you don't have enough data space on your computer for large amounts of data, you can use a sample. So we're going to do a sample size of 10,000 because I don't want this demo running for too long, and the sample size of 10,000 should mean we can get the data extracted fairly efficiently. And then finally we've got this washout period, which means that this is the number of days of observation prior to your cohort start date that you need to be included. And this just means that we want people to have at least a year's worth of records in this case. You might want more, you might want less, but that's what the washout period means. And then we're going to run this code, and this is going to take some time. So you can see here we're sampling the 10,000 people. We've connected to a server, we're sampling the 10,000 patients from a target cohort, and then once it's sampled those 10,000 people, it's going to then start extracting the features. It's going to create them and start extracting them, and then it will extract the outcome as well. So we'll have that outcome cohort, so we can use that for when we're doing our time at risk calculation. This is going to run for quite some time. So because we're extracting 4 different condition settings for the 4 different time periods, the constructing the features might take a couple of minutes. So you'll see the progress when you're running this. When you do it yourself, this progress bar tells you how long it's going on, and you can see if how close you are to actually getting the data. But rather than focusing on this for too much more, while this is running, I'm actually going to go on and continue with some other bits, and then we'll come back to this once it's extracted all the data. So if we look down now, the next step is this create study population. So in the patient level prediction, create study population is what's used to define your labels. So this is where you actually specify your time at risk, and it will actually say for each person in your target population who has the outcome during your time at risk. So this population that you get returned, so on row 39, this population is going to be a data frame that effectively has your target population cohort, and then it's going to have appended onto that the label, did they have the outcome or not. So in this create study population that we see here, the first input that you're going to be using into this create study population is the PLP data. So once we've got that extracted, we can actually run this. For now, we're just going to have to wait for the PLP data to download. But the PLP data just contains your cohort, target population, it's got your outcome cohort, and it's got the covariates. So that will be, and then you'll have your outcome ID, because you can actually extract multiple outcomes. So we just have a one outcome ID. So that's the case. So then required time at risk. So required time at risk basically says what you would do with people who are only partially observed during your time at risk. So say your time at risk is 1 year from your cohort start, but someone drops out after 80 days and they haven't had the outcome. We don't know whether they could have had the outcome if they continued being observed for the whole time at risk. So if we include them in as someone who doesn't have the outcome, we might actually get some noise. So required time at risk set to true means that people who aren't observed for the minimum time at risk that you specify will be excluded from the population. So those people in the target population who aren't observed for the minimum time at risk days will get excluded from the population. And then so that's why the second input below this is the minimum time at risk. And in this case, the minimum time at risk is set to 364 days. And that's because we're looking at a risk start of 1 and a risk window end of 365. So this is actually the whole time at risk period, as you can see there. So we're actually saying here we remove people who don't have the outcome if they're not observed for the whole 364 days of the time at risk. But then this one below says include all outcomes equals true. So what this is saying is, if you have an outcome at 8, and then if you have the outcome say day 40 and then you leave your observation at 80, leaving the observation is not going to stop the fact you had the outcome. You're already an outcome person. So we set this to true because we're going to say we're going to keep all the outcomes. Now this could cause a bias because you might find that the people who have the outcome, they could die, for example, whereas the people who don't have the outcome, they can't die within that time at risk. So you can get a bias with this that you have to consider, but we're going to include everyone in outcome. Then you've got the add exposure days to start. We're going to put that as false. This basically means that you're going to do your risk window, your time at risk start relative to your cohort start date rather than the end. Then your risk window start is 1. So in this case, our time at risk start is the cohort start date of the target group plus 1 day. The next input is your add exposure days to end. And again, this is false. If you set this to true, it means that you'd be using your cohort end date as to basically to make it relative. That's when you'd end your risk period. But at the moment we set this to false, so we're doing everything relative to our cohort start date. And then that means because the risk window end is 365, our target time at risk end date is the cohort start date plus 365 days. So this is all just setting your time at risk. And the washout period, again, it's the same as what we had in the get PLP data. We set this as 365 days. They must have had at least 365 days prior observation to their cohort start date. So that's the create study populations, which defines the time at risk. We've now got our PLP data extracted that took it took 4 minutes really to extract, to do the majority of that SQL. So that's all set. And then here I'm just going to explain. So we're going to use a lasso logistic regression. There's lots of different models that you can pick, and they're all set, and then the model name. We've picked a lasso logistic regression because it's the one we tend to default to first. But there's lots of different classifiers you can pick, and they have different hyperparameter inputs. But with our model setting as lasso logistic regression, I'm now going to run the population creation. And that's basically going to get our time at risk all set up for us. And then I'm going to run the model setting to get the lasso. And then the next bit is this patient level prediction run PLP. So you put in your population, PLP data, the minimum covariate fraction. So this is the minimum fraction of people that need to have a covariate AK feature for it to be included. If a covariate is very rare, then you there's not going to be much use in the model, so you might as well get rid of it. So that's a input you can set. Then it's whether you want to normalize the data, true or false. And then the next bit is the model settings that we did on line 50. So this is saying that we're going to use a lasso logistic regression. Test split tells you whether you want your test train split to be just randomized by person, or whether you want to train on old and test on new, which would mean you'd need to test split equals time, not person. And then you've got your test fraction below this. And the test fraction tells you the fraction of your target population that's going to be used for the test set. So these are going to be people that will be used to evaluate the model and not used to train the model. In this case, we picked 30. The next bit below, we've got split seed. So this is just whether you want to use a seed for doing your test train split so that you can reproduce it. I've put the split seed in so that it's reproducible in the future. Then below the split seed, you have n-fold, and this is how many folds you're going to be doing when you run your train your model and use cross-validation to pick the hyperparameters. So I've put n-fold equals 10. It's the good default one to do, but this will depend on your data size. And then finally, analysis ID is just an ID you can give to this analysis. So I've called it PLP demo, but if you're doing a different study, you could put an informative name here. So now if we run this run PLP, we're now in a situation where we've got our data, we've set our time at risk. So now it's actually just going to start creating the model. And as you can see, here's information, tells you information that's progressing. The model's trained very quickly now because we've only got 10,000 people. We actually trained the model extremely quickly. The lasso distribution was trained, and we've got an error curve of 63 on the test set. So this is actually now, we've got our model trained for the single PLP case. And what I'm going to do now is just run through some of the outputs that we get. So if we look into this result object that was returned, what do we get? We get an input setting. This tells you all the settings that you chose, from the time at risk, from the feature extraction, everything that you wanted is saved there, so you can look back at it into some future point in time. So this is useful if you come back to this model. Then you've got the execution summary, which tells you how long everything ran and some information about the computer. You've got your model, which is the actual model that you've trained. And then you've got this prediction data frame. So I'm going to look at this. If we look at the first row, we can see this tells you the row ID, the subject ID, the cohort, target population cohort ID, the cohort start date for that person. And then you've got information about how long they're observed prior to their observation start. So this person was observed for over 10 years before they're included into the cohort. And then you've got this days to cohort end. So this is like how long they're in the cohort, which is quite long, 300 days. Then we have days to observation date end. So how many days they're observed before they exited the observation period, and whether they have the outcome or not. So outcome count is 0 if they don't and 1 if they do. And then the next thing to really look at is the index, tells you whether it's a test or train. In this case, this was used as a test person. And then we have the predicted value. So this is saying that they had a 3% risk assigned to them by the model. So you can actually get that prediction for everyone in your target population. And then we're going to look at performance evaluation. So, covariate summary. So covariate summary gives you information about all the different covariates. So if we look at the first row, we get covariate ID. We know it's covariate name. So what this is age group 0 to 5 to 0 to 9. And then we got how many people had that in the data. And we can look at what was the mean with no outcome. So people who didn't have the outcome, how often this occurred. People who did have the outcome, how often this occurred, which was 0. And then you can look at the train and test information. So you can see if it was well distributed between the train and test sets. Okay, so now I'm going to look at the performance evaluation. This is the meat of the results. So this is going to tell you some summary statistics of how well we actually did when we trained the model. So performance evaluation has 5 different bits. Evaluation statistics will tell you the evaluation, so whether it's a train or the test, different metrics and the value. So you can look at how many people there were, you can look at the area under the curve. So if we look at the area under the curve for the test set, it was 0.63. And then you've also got the area under the precision recall. And then you've also got information about the calibration. So this is just the general information you'd want to look at when you're doing a prediction model for the test and train. And then you've got all these other ones that just summarize different thresholds of the prediction or the demographics and the calibration. Now, I'm going to show you the plots that you generate from these rather than go through them. But if you're running this yourself, like it's good to go through and actually have a look at what's in there. So if we now look at some of the plots that are available in the patient level prediction package, the first one that you'll probably want to look at is the sparse ROC. So this will actually be using the information that's in the performance evaluation to generate a ROC plot for your, by default, test set, but you can also look at it from the train set if you wanted that. So this will pop up in the bottom right hand corner, and we can look at the zoom now to actually see it in a bigger pop out. So you can see here, this is the ROC plot for our model, and then we can look at other plots as well. So another one that's nice to look at is the demographic calibration. So the demographic calibration is used to see how well calibrated your model is against the different age and gender groups. So the red is the observed and the blue is the predicted. If the red and the blue seem similar, or the blue follows the red trend, then you've done a good job on the different age and gender groups. If it doesn't, then you might have to separate out your cohorts into different demographic groups. Now if we look at the sparse calibration, this will tell us how well our prediction matches the observed predict probability or observed fraction of the outcome. So you have predicted against observed fraction. If it's good, it should fall on the x equals y line. This doesn't seem calibrated the best, but it also isn't completely terrible. And then we've got lots of different plots, but one other one that's worth looking at is the precision recall plot. So this gives you a nice visualization if you have rare outcomes. This is actually worth looking at. So the red dot is just the incidence in the target population of the outcome, and then you can actually look at how much improvement you could get in your model. So we could actually identify, we can get a precision of 16% even at a very low recall compared to the precision that's actually under 0.4 in the general population. So this is an interesting plot to look at. So this is the PLP single evaluation. We're going to be doing the multi-PLP. Oh, so actually before we finish, let me just show you how to save. So you obviously, once you've done this results, you don't want to have to rerun this again. So you can save this by using save PLP results, and then you put your result in and you put the file path. So patient level prediction, save PLP result, and you just put your result with the location you want to save. And then if you want to load this, you basically just replace the save with load. So it's load PLP, and you just put in the location where you saved it. And then that means you can get this again in the future. By default, actually, you will have this saved when you do the run PLP. It will actually tell you when it runs it that it's output everything, and it saves the data, it saves the model, and it saves other plots and such. So by default, you actually have this anyway, unless you turn off the saving. But if you want to turn off the saving and manually control it, this is how you save and load.